I'm trying to go on live also so that we can have the recording. Okay, who is this? Why are they drawing things on the dashboard? Okay, I think I'm trying to go on live also so that we can have the recording. Okay, okay, who is... Sorry, 1 minute, please. In the settings. I need to clear up this whiteboard. Please, can you clear up this whiteboard? Or let me do this.
Okay, sir.
Looking for you. Don't worry. I'll just... Sorry, because it's the first time we're trying to set up properly. Okay. All right. So please, can you confirm that we have the... Can you confirm that we have the... That we have the live streaming working now? Okay. All right. Okay, so I will just do it again by sharing my screen so that we can start today's session. Okay. All right. So last time we discussed, right, on week one, our discussion last week was on green and diesel economics. And this week, we want to talk about the energy cost breakdown. Like I said, the model of this our training would be an interactive training course. And of course, what we have adopted is a session where we have paragraphs to be read. We have questions. We'll review the case studies in those paragraphs and have it to be very interactive. Please be on hand so that you can, unmute participants, that would want to, by way of comment, volunteer their comments on this in this training. So to start with, we want to start with the first part, which is the modern utility billing. The modern utility billing. We are used to receiving costs, energy bills, meters, especially in this side of where we stay. Everybody wants to be metered, which is the right thing to do. But we'll talk about what are the type of utility billing and, of course, some of the challenges we even have when it comes to billing, metering. So when we say utility billing, we are talking about metering, right, of this of energy consumption. So to start this part one, I would like someone in the audience read the paragraph 1 and 2. Now, under part 1, there'll be questions we'll review, and there'll be other comments we'll also get during the course of this part. So, can we have someone raise his hand and to read 1 and 2 under part 1? And please, you can do well to unmute the person. Can we have raise your hand? Okay. Okay, let's start with Kike. Kike, you'll be unmuted now. Yes, you're muted. Can you read paragraph 1 and 2?
Yeah, all right. In the realm of energy management, many facility owners mistakenly view their electricity bill as a simple total for units consumed. However, the modern utility bill is a complex document that reveals the efficiency of an entire operation. For large consumers in Nigeria, Kenya, or Rwanda, the bill is divided into two primary categories: energy in kWh, which means kilowatts per hour, which represents the volume of work done, and demand, kilowatt slash kW rather slash kVA, which represents the maximum speed at which energy was drawn during a specific window, usually 15 to 30 minutes. Paragraph 2. The demand charge is particularly significant because it is often logged in. For instance, if a factory in Lagos starts all its heavy machinery simultaneously at 8 a.m., it creates a massive spike in the grid. Even if those machines only run for 20 minutes, the utility companies such as EKEDC may bill the customer for that peak level for the entire month. This is because the utility must maintain transformers and wires large enough to handle that specific peak, even if it only happens once.
Thank you. Thank you very much for that reading. Now, so like I said, this is really the pattern we would have our session, and there will be questions. Some of the questions would be maybe found in the paragraph, some would be outside the paragraph. And this paragraph, yes, we'll be using some specific areas, like for example, Nigeria, Kenya, Rwanda, and also some specific companies, but it also apply not necessarily to that company, but it's just an example, right? Now, looking at this paragraph, we're talking about modern utility billing, and I'll give an example. We've had a case where we had something like the national grid shutting down, the national grid shutting down. The grid reached its maximum capacity, right? And then there's an overload and things like that, or maybe also for some reasons also, some of the times why the grid shut down might be vandalism. But we say national grid shut down based on overload. And which is why we want to talk about this today, right? Now, so I want to ask some questions. Some answers are in the paragraph, and we can also answer outside the paragraph. And the first question is, how do many facility owners view their bills, and why this is a mistake? Is there anyone that want to take that? How do many facility owners view their bills? How do many facility owners view their bills? Based on the paragraph, what can we denote from that? Okay. Ali, Ibrahim. Ali, you can unmute.
Hello. Hello.
Yes, Ali,
Yeah, can you hear me?
Ibrahim.
Yeah. Okay. Many facility owner may be selling you their electricity bill as a simple total of all units consumed instead of the modern way of looking at the bill, which is a complex document that reveals efficiency of the entire operation.
Thank you very much. But why can we say this is a mistake? Some will just see, okay, this is how much I've consumed this month, right? And that is what, in fact, many of these facility owners, right, that is what they want to see at the end of the month, the unit consumed. But why can we say it's a mistake sometimes? Why can we say it's a mistake?
Well,
Patrick. Yeah, let's have Patrick.
All right.
Okay.
Yeah, good morning.
Patrick.
Can you hear me? Am I audible?
Yeah, I can hear you.
All right. My name is Patrick. So, most times facilities owners do the flat rate, like the last speaker mentioned, which is a kilowatt hour. Now, it is a mistake because there are times that even though they might or they may be called facilities, there are also sometimes during the day or maybe at night that they usually demand a very high amount of energy that falls outside the range of the usual energy demand. So I think that is why it could be a mistake for them to do the flat rate charge. Thank you.
All right, thank you. Thank you for that, Patrick. Are there other comments why we can also say it's a mistake? The way most facilities look at their bills these days. Okay, now let me give this example. Imagine you have a solar, okay, we have someone, let's see. Okay, let's hear from Gabriel.
Okay,
Gabriel, yeah.
thank you very much. Most of the time they look at the billing as based on the number of hours used, and also they look at it. There are some certain things like fixed charges. They don't agree with that because they don't know that. And where I live, and in most places in Nigeria, they bring about what we call estimated bill. And many people are not happy with that. And facilities owners too are against that. Thank you.
Thank you very much for that. Thank you. We have Kali. Kali, you can speak now.
Yeah, thank you very much. Can you hear me?
Yeah, I can hear you.
Yeah, from this work you printed, we can see that there are two ways at which they calculate the energy consumed, either by the work done or the speed. So usually during that speed, which is the demand, the maximum speed, which is just 15 minutes or 30 minutes. So that 15 to 30 minutes is what they will now use to calculate the whole day, which is a mistake. I think that's a mistake also.
Okay, thank you for that. We have Ali.
Yeah,
Ali,
yeah. Good morning, sir. Thank you
morning.
so much. Really
Thank
appreciate
you,
your
yes.
input. So let me just go quickly to the questions. In my own opinion, the way the billing system that we thought that they are not so accurate is that the billing in this place, Abuja to be precise, we have different bands to which they supply and the needs of the customer. So they categorize those bills based on the customer usage. There are some
Good.
customer usage that's band A that they always give them 24 hours electricity. So that their own payments is going to be different with band B, C like that. So the grading system of it determines the cost. Then they now rate it based on the usage of it, the user himself. Thank you so much.
Thank you. Thank you very much for your answer. Now let's take this a bit further. Right now, imagine a community or an area that that have both those who are high energy consumer and those who are very, very low. I don't want to use poor, but they are very low energy consumer. They are not able to pay premium rates, right? Now, how is this type of billing system a mistake? Or let me also ask, for those in Nigeria, of course, we also go in Kenya and Rwanda, but for those in Nigeria, what are the common challenges do we see with this type of billing system? Whereby they say an area is band A, another area is band B, and things like that. And also those areas in band A, many people cannot pay for the energy. What is the mistake? What is the mistake in that type of billing system? What is the mistake with that type of billing system? Did we get the question? What is the mistake with that type of billing system? You have an area band A. In that area, okay, let's listen to Solomon. Solomon Tunde. Solomon Tunde, you can unmute yourself. You've been granted.
Okay, good morning, everybody.
Good morning.
Yeah, for the billing methodology that is band A, band B, wherever, I think the way this thing is being adopted is once the disco fill, they can actually give you supply, that they can give you a minimum of 20 hours supply. So what the NEC principles say, they must run that minimum of 20 hours supply for 3 weeks. Once they were able to do that for 3 weeks, they can give that place 20 hours, minimum of 20 hours for 3 weeks. Then they upgrade them to band A. And one of the major constraints here is that the law says if they could not meet 75% of that supply in a month, they must be downgraded to band B and they must compensate the customer. But usually nobody knows that. So everybody
Now,
just
what are
keep
the
quiet. So most disco usually know that. And based on, maybe, I don't know, maybe there is no serious monitoring, but from what I know, the NEC actually install certain parameters at the disco level, at the transmission level, so that they the consumption they are. So there's a parameter that they are, but usually whenever they tell the disco to downgrade and compensate other people, normally they don't do that.
Okay, all right. Lastly, Patrick, thank you very much, Solomon. Lastly, Patrick, yeah.
All right. Thank you. Thank you for that. So I think there are so many errors in this band A, band B, and band C thing. Personally, I feel that band A are placed based on how easy it is for them to be supplied constant electricity. Now, it does not also take into cognizance those living within that area. Now, number one, if they are willing to pay for band A, and if they can. Now, it is one thing to be willing, it is another thing to be able to pay. Now, there are a lot of people as well who are in band C, in band B and band C that can pay for what band A are paying, but they do not have the transmission line around those areas that can put them on band A. Now, this leads to a lot of things for EKEDC, for IKEDC, for those who stay in Lagos, for IBDC, for those who stay in Ibadan, and all other firms like that, that they do not get what they really want. Now, those who use band A, they are very energy efficient. I don't have my facts, but I doubt if you can get any form of demand charge from those type of people because they know how much money they pay. Now, in contrast, those in band B, they pay, I think, around 64 naira per kilowatt hour. That means that they believe and they feel that they can use energy the way they want because they can afford to waste energy. Now, those are people that ought
Okay.
to be paying for demand charges that are not even paying for them. So there are a lot of things that needs to be sorted out in that band A,
Okay.
band B.
Thank you. Now, what this modern utility billing method that we just read is suggesting is there are two primary categories, right, that bills can be separated to. I know that in Kenya, they do that. There's what they call demand. And demand is talking about the speed of energy, how much you are drawing in energy in a specific window. Let's say 30 minutes, how much energy are you drawing? And that is what will be used to determine how much your rate would be or how much you'll be billed for. And in a case where in Nigeria, people are talking about targeted subsidy, targeted subsidy. So let us give a case study. You have a 150 um, kilowatt system, whether it's generator, whether it's um, um, whether it's solar system, mini grid, right? And then you're serving a group of people. In that group of people, you have those who are energy efficient, you have those who do not have enough purchasing power, you have those who have enough purchasing power, you have the industries and things like that. I'm just giving a case that imagine you're supplying this power to that group of people. It's a mixed group of people. For us to talk about modern way of billing people, right? What this paragraph is suggesting is that we can do it in two ways. The first is, and which is what we will discuss later, the reason why is if, for example, I am demanding so much to keep my operation running, right? I'm a manufacturing plant, for example, and then my demand is at a level. My rate should be sort of different because I'm talking about speed, because I'm demanding so much on the system than someone that is just demanding for a bulb, right? And this is what we are talking now. The second question now is now where we want to answer more, and which talk about what is the difference between when we say kilowatt hour energy and demand. What is the difference? What is the difference between these two? When we say energy, when we say demand, what do they mean? We need answers. What do they mean? Energy and demand. What is the difference between energy, kilowatt hour, and demand? We can also get the answers there in paragraphs also. Okay. Odetunde, please unmute yourself.
All right. So in terms of energy, it's like the amount of power you've consumed over a period of time. But for demand, is actually what you are consuming as it was stated in the document in its specific duration. So energy this is the amount of power you've consumed, let's say in 10 hours, in 20 hours. But power speaks of real time consumption of energy.
Thank you. Thank you very much for that. Do we have other comments on that? Okay, I think you spoke very well, right? That is the answer. Okay, we have Toby Victor. You can unmute yourself, Toby Victor.
Okay, good morning, everybody. For me, I would say energy is the total electricity a facility use, right? The total amount of electricity used and why the demand is, I think, how fast you use that electricity in a given moment also.
Thank you. Thank you very much. And that is the answer. Now, looking at this paragraph 2, it gave an instance, right? And of course, if you look at my explanation earlier, I have started applying these instances in different scenarios, right? But you know, uh, the question now is, why does that 20-minute spike in usage affect the cost for the entire month? Why would we say we want to justify that, oh, someone that is using a larger, equipment and someone that is using a lower equipment, right? Why would we say that 20-minute spike, 30-minute spike, if we want to have a window of 60 minutes, should affect the cost, the tariff of that person for that month? How can we justify that? It's in paragraph 2 also. Okay.
Right.
Okay. Are there hands up?
Yeah.
Okay. Yes, Patrick, let's hear from you.
All right. Thank you. So I think we need to also understand why we also charge for demand cost. Now, it is used to maintain the electricity infrastructures. For instance, for your wires and the cables and all. So now, the reason why it's important is because at that 20 minutes, when you are demanding a high energy, the wires and the cables and your transformers are doing extra job, extra work for you to get that level of electricity delivered to your facilities and to your appliances. So I think that should be a very good justification. I don't know if that answers the question. Thank you.
Yeah, thank you very much for that. Are there other comments? Gabriel, let's hear from you also. Gabriel,
Hello,
okay.
can you hear me?
Yes, we can. Yes, we can hear
Yeah.
you.
This demand, I'm looking at it also as a power factor. I'm looking at
Okay.
it like that because power factor has to do with the power in kilowatts divided by the kVA. So I'm looking at it
Yeah.
like that. I don't know. And actually it tells about the efficiency.
Good.
But I'm
That's the
looking
true
at
power.
this.
Okay.
Yeah. I'm
Okay,
looking
yes,
at it.
we have John. John wants to also say something. John, please.
Okay. Okay. I I think I want to toe the the line of the person who spoke before this last speaker.
Yeah.
I look at it that when we pay these electricity bills, part of it goes back to also
Maintain.
maintain, yes, because these infrastructures too they deteriorate with time, and so we also have to, I don't know what, I've forgotten the term that they use, but it's like every bill you pay now, part of it goes back to equally paying for that infrastructure. And so when within a short space of time um you have to demand a very large volume of energy, and I think what it means is that the particular infrastructure should be able to support that energy, because if it doesn't, then that means the consumer will not be able to get it. So I think that justifies the fact that you have to pay an extra bill, for using such this thing. Whether you do it once or maybe you might also, that spike might occur maybe any other time in the month, but it just means that at any point in time you have such demand, then the infrastructure should also be able to support it. So
Thank you.
that's my take.
Thank
Yeah.
you for that. Thank you for that. We'll take two more comments. Let's hear from Richie. Rich, let's get to hear from you. Then afterward, we hear from Adeola Oluwaseun. And we'll go to the next. Yes, next part. Richie, Rich, unmute yourself. Yeah.
Okay, good morning, everyone.
Wonderful.
So I wanted to, it was actually going to be a question, and that is, could the charge for the peak level for the entire month could be that we are trying to anticipate that this behavior will continue over time for the entire month, and probably not just continue for just 20 minutes. Maybe it might extend to 1 hour, because there's no way we can really predict if this factory will keep using their heavy machinery at this same time for this duration of time every day. So could it be that the reason why we are charging them, they are being charged at that peak level for the entire month, is to anticipate that, okay, these people could either maintain this energy level or use more over the entire month, over the course of the month? So that's what I'm just asking. I need clarification on that.
Okay, all right. I will answer your question. Well, let's hear from the next comment before we take that. Oluwa Adeola, can you speak? Yes, Adeola, please speak. Oluwaseun.
Yeah, can you hear me? Hello, can you hear me now? Hello, can you hear?
Oluwaseun.
Hello.
Yes, I
Am
can
I
hear
audible?
you. Yes,
Okay,
I
so
can hear
like,
you.
okay,
Yes.
like there's the term has all-day effect. So I think it's the all-day effect that affects this maximum demand stuff. So I've worked as a maximum demand officer with one of the electricity company in Nigeria. So factories has some spike moments. I think from around 8 to like 12, and most factory run shifts, and mostly at night. It affects the demand of other customers. Everybody's at home at night, and factories also run shifts at night. And most productive factories do most of their productive time at night. So this also justifies the hike in charges. So then I think we charge over one. I think before band A issue came in, we charge our maximum demand, I think, around 90 naira per unit, and the others, I think, around 34 or 20 something there about that time. So when band now came in, I think the companies still maintain their plans, but their prices was also hiked too. So, but one of my own concerns too about this is that if energy were to be surplus and in more quantities, the cascading method should have worked, which will cascade industrial use to domestic use, so that we won't have, sometimes the spike of industrial use shifts into the demands of the domestic use also. You can't say because we have industries that when I get home at night I shouldn't have light. Because even many industrial workers still work from home to maintain that would happen the next day. So I think it's still because our energy is not efficient in most African countries. We still need more energy to be supplied. Imagine Nigeria generating less than 5,000, and we are more. We need over 20. So when we have 20, they will be cascading. Industrial will not interfere. I work with a manufacturing company now. Imagine grid collapse when we are producing cereals. Imagine the cost that it will incur, the loss that it will incur, the waste that we generate to the environment. So I think it's still because our energy supply is still low. That's why the thing is still, we are still having so much issues with demand and also. So that's my take, Sha.
Thank you. Thank you very much. So basically, to round up this, what we are saying is, if you are, whether you are working with a mini grid and things like that, we should have what we call the cost reflective tariff, which is what we've been talking about for a long time, even in the energy space. Because the problem with Nigeria energy sector is not energy generation. Yes, we also know energy generation is there, right? But the fundamental problem also is the fact that our housing system is not organized, right? And that is what is also causing issue in recovery and things like that. Let's give a case now. A case is, we have an area that is supposed to be mapped for industries. In that area, you still see people, you still see residential in that area. You have an area that is supposed to be residential. You still have industries, the big men coming there. So, and this is what causes problem. And that is why you see, even with the band A, band B, band C, and things like that, the grid is not still stable, right? Of course, we know that the demand is more. We are not generating much, but the one that we're even generating, let us manage it properly. So let's move to the next part, which is what someone was commenting on the last time, right? That the power triangle and system efficiency. Let's have someone read this paragraph, the 3 and 4 for us. Can we have someone do audience? Let's have someone read it. 3 and 4. 3 and 4.
All right. Sir, can you just scroll up a little bit?
Okay.
Okay, yeah. So, yes.
All right, I
Scroll
came
up.
back. Yes. 3
All
and
right,
4.
yeah. All right. So part 2, the power triangle and system efficiency. To understand why a bill might be unexpectedly high, we must examine the power triangle. This consists of real power, P in kilowatt, reactive power, Q in kVAR, and apparent power, S in kVA. Real power is a useful energy that turns motors. Reactive power is non-working energy needed to maintain magnetic fields. Apparent power is the total sum of both. We can illustrate this with a glass of beer. The liquid is the real power we want, while the foam is the reactive power that takes up space but does not quench thirst. 4. The ratio between real power and apparent power is known as the power factor, PF. A power factor is 1. A power factor of 1.0 is perfect, meaning there is no foam. However, if a factory has a power factor of 0.7, it means 30% of the energy being supplied is wasted as foam. Utility companies fine or surcharge customers for a low power factor because this wasted energy clogs the grid's wires and transformers, preventing the utility from serving other customers effectively.
Thank you. Thank you very much for that reading. Thank you very much, Patrick, for engaging actively. Now, let's take the first question and let's get, oh, this thing is going back. Now, the first question would be, the first question is, what are the 3 components of a power triangle? Okay. We have Ugu Kelechi.
Okay, good morning. We have
Morning.
real power, reactive power, and apparent power.
Thank you. Thank you. Now, if we want to explain it using the beer, and thank you very much, Kelechi. If we want to explain it using the beer analogy, how can we explain using that beer analogy for to understand reactive power, or using a soap? This soap, let's say beer analogy. Yeah, how can we explain it? Or even using a soap analogy, a liquid foamy soap analogy. Okay. Yes, let us hear from Adebayo. Adebayo, meet yourself.
Okay, good morning, everyone. It's actually as simple as we can see it. The liquid is the real power, foam is apparent, and foam is the reactive, and total, that's the sum, is the apparent power.
Good. Now, they say, how does the beer analogy help us understand the reactive power? Let's mute ourselves. How does the beer analogy help us understand reactive power? Okay. Kali, unmute yourself.
Yes,
Unmute.
it is Khalil. So the
Khalil,
way
okay.
yes, ma'am. So as they have said, the foam, we will drink the foam, but it won't quench thirst. Just like soap also, if we are trying to wash our clothes, the foam that generates when we are washing, it cannot clean the clothes, but the water itself, we can use it to wash the clothes or rinse the clothes like that. So it is just the reactive power, it is not doing it. Thank you.
Thank you. Thank you very much. John Wabuko.
Okay, so I think using the beer analogy, you know, let's say for instance now we have a particular level of glass and the liquid, which is the beer, now we want to fill it. When we fill it, we actually expected to, when we drink that beer now, we get complete satisfaction. That complete satisfaction now is when the power factor is at 1. Now let's say for instance now that the foam now, which is the reactive part, occupies some percentage of it, which is like maybe 30% now. In that case now we have a real power of 70, and the foam now which occupies 30%. Now we all know, for those of us who have taken beer, that when you take that foam, it actually doesn't translate to real satisfaction of that beer. Where you get that satisfaction is the liquid part. So that part just occupies space. So for me, it's just wastage. And so that 30% aspect is just like the when you look at it, it's inefficient in terms of giving you that satisfaction. So it's wastage. So the more you have that foam, assuming that foam gets more, maybe like 70%, that means that you only just have 30% of satisfaction. So the lesser we are able to make that foam, the more satisfaction we're able to get. So meaning that if the PF is more, then that means we have more real power, and we get more satisfaction. We get more quality power and less wastage. So that's my take.
Thank you very much for that. Now, the reason why we are talking about this is because we are talking about energy costs. Most facilities are not aware that there's a lot of wastage, and that is what is affecting their energy cost. I was looking at a bill They already have meters in that facility. The meters are reading in kilowatt hour. But when they are receiving the bill, because of their power factor is very poor, they have what they call a subcharge. A subcharge. Sometimes when you look at your bill, there's a multiplier. If you see 1, that means you are not being subcharged. But sometimes you can see 1.26. That means your bill will be multiplied by that, and then you get the total amount of that. And now the last question for this part now, before we go to other discussions, will now be, why is the low power factor considered clogging the grid? And what is the result to the customer? Why is the low power factor clogging the grid? And what is the outcome for the customer? Yeah, let's get more hands. I want more people to engage in this. We're all learning, and this is how we learn, right? We don't just want it to be one-way traffic where we just come and start talking, it's not interactive and things like that. By the time we hear this comment from each other, we get to learn and improve, right? So let's hear from Engineer Peter.
Thank
Engineer
you.
Peter.
Good morning, everybody.
Good morning.
I believe I'm audible enough.
Yes,
All
you
right.
are.
When we talk of low power factor, we're asking how is a low power factor clogging the grid? What actually happens when we have a low power factor like about 0.3, 0.4 and all that, like we rightly saw in our manual just now? It means you are wasting, if you have a low power factor, for instance, as against almost unity power factor, it means you are wasting a lot. For instance, now if a facility has a power factor of 0.3 or 0.4, it means that 70% of the power of that facility is being wasted. It's only 0.3 or it's only 30% or 40% that is being utilized. So what it means is that as you attain or as you approach towards unitary power factor, for instance, then it means you are energy effective or you are energy you are energy effective. Thank you.
Yeah. Thank you very much for that comment. Very lovely comment. Let's hear from Lois Moses. Lois, unmute yourself. Let's hear from you.
Okay, I'll just try by saying, like you said, there's so much being wasted because using the analogy of the foam, right? There's a lot of energy being diverted to that particular facility, and then not much of it is being used because a lot of it is foam. So technically, you are not allowing them to provide as much electricity for others that need it as well or have high demands too. And then you are not necessarily making use of it because much of it is being wasted. So it's a waste in essence.
Thank you. Thank you very much. Now, how does this affect, what is the result? How should this affect the customer? How should this affect the customer? And how should this affect the customers? Okay, Wale Sunday. Wale Sunday.
Yeah,
Yes,
good morning,
yeah.
all. Good
Morning.
morning, all.
Good
Yeah.
morning.
So since the customer they are wasting the power, and when other people supposed to that need power are not getting it, so they will have to charge them more. They have to pay more. They have to pay for those wastage, so that it will not lead to a losses to the grid management.
Thank you. Thank you very much for that. Yakubu Abdullahi. Yakubu Abdullahi, you can unmute yourself. Let's hear from you.
Hello, good afternoon, everyone.
Good
I
afternoon.
think the angle that's affecting the customers is through the power lines. I think, and then the maintenance of for the maintenance of the transformers, because most of the maybe the power supply for some areas, they need more of this transformer, because the transformers cannot serve the area. And then you see that even if there's like some places will just be changing. And then even the network, the power networks too are not efficient to supply are not efficient to supply the power customers. I think these are the angle where it affects the customers.
Thank you.
Thank you very much.
Thank you. Thank you very much for that. So, of course, we've seen that it's important because there's a lot of wastage. Now we should start thinking, right? In our system currently, are there wastages? If I am generating power, supplying power to communities and, even in our industries, right? I'm an energy expert. Do we monitor the power factor? Do we ensure that the power factor is at least we keep 90%? And of course, as we see in other parts, we see how we can regularize the power factor, because this will affect the cost, the energy bill at the end of the day, right? And there's a formula for also even getting the subcharge, to charge a customer. So it's important that we should it's important that we should always check the power factor and get to know how this would affect our bill. Now let's move to the third part. I'm going to take this down. Now the third part, right? We have about 6, 7 parts. So let's move to the third part for today. And another thing we want to talk about that affects the energy costs is what we call harmonics. We've talked about power factor, right? We've talked about demand, which is of course something we need to look at, right? Because, for example, if it's a manufacturing plant, for example, like the case study we had, right? Instead of putting up all the load at once, right? Why not cascade your load? Put on a pump first, then the next 30 minutes you start up sequentially, which is why you see even the plants are doing that. So let's move to the third part that affects our energy costs, right? As energy manager, and this is what we call harmonics. Harmonics. Many people have heard about harmonics, or may have not even heard about it. But let's see, how does harmonics affect our power cost, and what is even harmonics? Now, let's have someone read this part 3 for us. Part 3. Let's have someone read it. Dennis, please. Dennis. Read the part 3.
Good afternoon, everyone.
Unmute yourself and read.
All right. Good afternoon, everyone.
Good afternoon.
Part 3.
Good afternoon. Good afternoon. Yeah.
Yeah. Part 3. The threat of harmonics and transformer losses. Number 5. Beyond the power factor, a silent threat known as harmonics often exists within a facility's electrical system. Harmonics are electrical pollution created by modern devices like LED lights and variable frequency drives, VFDs. Instead of a clean, smooth wave of electricity, harmonics create jagged, high-frequency noise. This noise causes transformers to vibrate and overheat, and it can even cause the neutral wires in a building to catch fire. Number 6. Furthermore, large facilities above 300 kVA are often metered at the primary side, the high voltage side of the transformer. This means the customer is billed for transformer losses. Even when no machines are running, the transformer itself consumes energy to maintain its internal magnetic field. An alert engineer manager knows that this no load loss can cost the company millions of naira or shillings every year if not monitored.
Thank you. Thank you very much for that. So let's take the questions so that we can discuss this together. The first question is, what are harmonics and what modern devices typically cause them? What are harmonics? Harmonics is answered in the paragraph. We want almost everyone to participate. What are harmonics? You can do well by just even reading the answer. What are harmonics? Okay, let's hear from Adebayo. Adebayo.
Yeah. Okay, good
Yes,
morning.
Adebayo.
Yes, good morning, everyone. Yeah.
Morning.
So, from my understanding, harmonics are electrical pollution.
Good. Thank you. Kali, I don't know if I answer Hali. Please unmute yourself. If I'm pronouncing it well, if I'm not, I'm sorry.
Yeah. Okay. Harmonics are electrical pollutions, and they are created by LED lights and variable frequency devices, VFDs, which is there in the slide. Yes, sir.
Thank you. Thank you very much. Some persons have noticed that when you check their neutral, yes, you can mute yourself, Ali. Yes, when they check their neutral wires, I don't know if you must have noticed it, it will be dark. It will look corroded. That's actually harmonics, right? Apart from other weather conditions that might cause that, but that's a sign of you are having harmonics in your system, right? And like you said, it can even cause a neutral cable to catch, fire. It can cause noise, unnecessary noise in the transformer, and that will even lead to overheating. And neutral cable can catch fire in the building. Right. So harmonics is one of the things that one needs to look at, might be causing unnecessary noise and pollution within the system. We have Mohammed. Please unmute yourself. You want to speak on this? Unmute yourself.
Yeah, what does it mean that the
I can't hear you, Mohammed.
Out of it, can it be applied?
Okay, I didn't
Because
get Yes, but you're breaking. You're breaking. You're breaking. Maybe you type your question, we'll answer it. Just type your question. Type your question on the chat. It will be answered. I hope I'm clear. Please, can you confirm that you can hear me? Maybe it's my network. Please, am I audible? Okay. Thank you. So I think it's Mohammed network. So let us move to another thing that, causes bills. That's what we call transformer losses. Now, the question for this now is, okay, yes, we've discussed what are the physical danger of untreated harmonics in a building. Like I've said, you have one of the ways you can know if you have harmonics in your building is to check your neutral, cable. Sometimes, your neutral cable will be heating. You see some black spots or even corrosion. You know that, okay, that you're having high harmonics, in the system. Now, I want to move now to transformer losses, right? Which is also one of the things that affect the billing in a community. We are energy managers. Someone comes to meet you and say, oh, when I collect bills from all the meters, yeah, and I compare with what I have, right, with what I have in in my MD meter or the bill I receive is not matching. These are some of the things, right? It's either you are being subcharged, right? You need to check your bill that you're not being subcharged for the high demand. You heard someone from one of the discos who work one who said they do that for companies and industries. It's either your power factor is being affected, that there are a lot of wasted energy. It's either you have untreated harmonics, and the fourth now is transformer losses. Now, what does it mean to be metered on the primary side, and how does this affect the billing? Yes, let's get hands. When you are metered at the primary side, what does it mean? And how would this affect the billing? It's a question.
Yeah.
Question. Primary side metering. What does it mean? Let's get hands. Let's get hands. I need other hands also. Yes, Kali, I see you, but other hands also. Let's get other hands. Okay, I think it's showing part 3, yes. So end on part 4. But let us take this question. What does it mean to be metered on the primary side? On the primary side. Okay, Sulaiman. Let us unmute you. Yes. And how does this affect the bill? Go ahead, please.
Good afternoon.
Good afternoon. Can hear you.
So we said there is a reactive power, which we said is wasted. So billing on the primary side, before the power enters into the transformer, when the power enters the transformer, there will be losses, such as the reactive power. There will also be heating. All these will be losses that will not be part of the power being going to the customer. So the difference between billing at the primary side and the customer side will be the losses in the transformer. So there will be difference. If both are compared, there will be difference between the billing at the primary side and at the secondary side due to the loss in the transformer.
Thank you very much. Thank you. Let's hear from Kolawole David. Kolawole David.
Hello, can you hear me?
Yes, I can hear you.
Okay, so another thing that I wanted to point out is that all those transformers, depending on how old their lifespan, the efficiency of the transformer also has a negative effect on what they will be consuming on the primary side. Sure, you understand? So apart from the transformer losses, apart from the fact that it's both reactive and then the active energy all combined, sure, you understand? Even the efficiency of the transformer alone, we also speak out for. just like when you are buying something on new, the efficiency will still be at its peak. So transformers that are of longer duration that have been used for so long, the efficiencies has dropped. Some unnecessary energy consumptions, some unnecessary losses will just be happening right inside of the transformer operation. Thank you.
Thank you. Thank you very much. Thank you very, very much. So we answered very right. Okay. Yakubu Abdullahi, do you have any comments? Then we take also Oshoba Oluwa Tomilore after Yakubu. Yes. Yakubu, go ahead, please.
Okay, sir. Good afternoon. I think what it means to meter by the primary side is that the power from the utilities is supplied to the transformer, even though it is not taken by the secondary side to the consumer, even though the consumer is not even using the power, but but it was already supplied to the transformer, and then that transformer need that light, and then because of even the oil that is there, at least to heat it up and then to be very effective at any moment when it is needed. That is part of it, why it is meter from the primary side. And then the customer definitely has to pay for it because it serves its own purpose to protect the transformer itself.
Thank you. Thank you very much. And lastly, on this paragraph, let's have Osoba. Osoba will definitely also. Yes, go ahead, Osoba.
Good afternoon, everyone. So I feel on this area of the primary side, the metering being on the primary side, I feel these facilities that consuming this large amount of energy are usually because of the fact that they consume a lot of energy, they cause these harmonics, these losses from the transformer. So that's the reason why they are usually put on the primary side compared to other consumers that are taking up low amount of energy. And in when it comes to the billing side, they usually build more because of the amount of energy they are consuming, and also because of the pay for the transformer losses as well too. Yeah,
Thank
thank
you.
you.
Thank you very much. There was a facility we visited. They were being built at the primary side, and they were complaining that, oh, when we get our bill, we do not understand it, this and that. When of course, it's a facility where they have other people being metered, right? And it's not matching in terms of what they are collecting versus how much they are being billed. These are some of the issues, that would cause it. Let us take the last part for today. Of course, there are 8 parts in this course. We'll take the last part, and then when we come back, of course, this material will be made available for us, and we'll get to have some assignments later. So someone is asking some questions. We'll answer our questions after this last part. Now, part 4 is the solutions. Try the solution for the energy manager. Try the solution for the energy manager. Now let's take someone to read the paragraph for 7 and 8. 7 and 8. Let's have Kelvin. Kelvin, can you read 7 and 8?
Yeah, good afternoon, everybody. Strategic solutions for the energy manager. The role of a successful energy manager is to use these forensic details to save the company money. By installing capacitor banks, they can eliminate power factor penalties. By using self-starters, they can shave the demand peak. In countries like Kenya, they can use time of use strategies to move heavy production to the night hours when rates are 50% cheaper. 8. Ultimately, energy management is about more than just turning off lights. It is a high-stakes financial strategy. By mastering the math of the power triangle and trimming of the grid, a manager transforms a facility from a source of waste into a model of efficiency. This not only saves money, but also extends the life of expensive equipment and contributes
Sorry.
to the stability of the national grid. Thank you.
Thank you. Thank you very much for that reading. So let's take the last 3 questions for today. Now, these 3 technical solutions an energy manager can use to reduce costs. 3
Capacitor bank.
Yes, so let's get from others. 3 technical solutions an energy manager can use to reduce costs. Let's get Hans. Hans. Let's get Hans. I'm waiting for Hans. Some people have not. Okay, someone in Kenya. Can we get someone from Kenya? I'm seeing the comments. Esther, can you tell us how it works in Kenya? If you are in the position to speak, can you just raise your hand? So that we can give you audience to speak. Esther, would like to get from someone in Kenya. If you're joining from Kenya or other countries, let us know. Just raise your hand or give a reaction if you are joining from Kenya and other countries. Drop a reaction. You are joining from Kenya or other countries. I think, please, the last time you asked, we got reactions. Please, are you here? Yes,
Yes.
let's hear.
Yes, we got reactions.
Okay. So let's see. If you're joining from Kenya or other countries. Okay. Let's take it then. List 3 technical. Okay, your background is noisy. Okay. So let's take it. List 3 technical solution an energy manager can use to reduce cost. Okay. Let's hear from Ali Ibrahim.
Yeah. Hello. Good afternoon, sir.
Good afternoon.
Thank you so much. My name is Ali Ibrahim from Abuja, Nigeria.
All right.
The way energy management manager can reduce costs, my own opinion, I'm looking towards maybe by conducting an energy audit and monitoring, maybe carrying out a detailed audit to identify the wastage points using smart meters, energy management system to track the real-time consumption of it, and maybe load optimization too. You can use load optimization maybe by eliminating the ideal load. Maybe if you have a 3-phase transformer, making it that those phases are being utilized very well, not that one is just to balance it up. Maybe the third one I can say efficient equipment upgrades, where you need to change some old equipment to maybe having an AVAC system with energy efficient option, using a lead instead of inverter AC, something like that, just changing them from within. So you can use it to correct it, telling customers how they can be able to manage their own energy too. So it will really save. Thank you so much.
Thank you for that. Let's hear from Chris Wanchuku.
Yeah, thank you very much, SC, and thanks everyone. My name is Chris Matuku, and the top three, I mean, from my own perspective, the top three approach for an energy manager to manage energy will be first and foremost energy efficiency. Retrofitting appliances and equipment into energy efficient appliances. The second one will be, using a mixed approach, energy source. What I mean is, instead of just having one source of energy, you could have a mix where you have like a renewable energy source still with the grid and other sources, so that depending on the market dynamics, you can optimize for the one that is most economical per time. And then the last one will be a time of use management, right? You figure out when energy is relatively cheaper to know when to run each equipment. For instance, if it's in a factory setting, if you have the mixed approach where you have a solar solution on top of your factory, you can prioritize running your equipment during the day. That way, you're also, optimizing on the cost of energy. Thank you.
Thank you very much for that. I mean, that comment is also very appreciated. So we've talked about several ways, and also when we say of time of use, is a strategy where you have different rates at different time. And in fact, if you look at the comments, they have confirmed from Kenya that yes, it helps them there, right? You look at your power, understanding your power triangle, right? Implementing, like I said, a mixed grid system where you have solar, you have other sources of power. So this is what we'll take for today. There are other parts which we would have to take it on our own. It will be uploaded in the Google Classroom. Please, we expect that by now everybody will be in the Google Classroom. Assignment for this week were not being marked, but we'll mark it, before Friday, because a lot of people are trying to, get to how they would use the Google Classroom. Now, I have one last question, and that will be the question before we take other questions. Please note the questions for us to take. We can also continue questions in our Google Classroom or in our WhatsApp. Now, the question I have is, given a case study of a facility, the facility have two sources of power generation. They have renewable power, and they also have from the grid. Of course, the facility demand is at let's say 300 kilowatts in terms of kilowatts, right? Their demand. Now, this facility have induction motors, compressors, and heavy equipment that are running. What safety solutions should the energy manager implement to prevent surge when starting up? When, for example, if you give a case study, power goes off from the grid, and then we're switching to the inverter, to the solar system. So what solution should the energy manager implement so that they would not be stalling in the system? The system would not break down or collapse. I don't know if you get my question. If you get my question, let me have a thumbs up first. If you understand my question, we have a system, a solar system, we have a grid. Grid goes down, you need to switch, but then we have every equipment in that facility. What are the solutions an energy manager needs to implement so that the system does not collapse when switching? Because of course the systems are running, and once the grid goes off, it will want to switch to switch to the solar mini grid system that was deployed. Answers. What solutions should the energy manager implement to prevent the system from collapsing? We understand we need answer. What are we suggesting, energy managers? So yeah, you can raise up your hand and speak. Let's get 3 comments on this. 3 comments on this. Raise up your hand. Let's hear from you if you want to speak. Why the one not seeing the raise hand? Okay. Yes, we have Jimo. Jimo, Sunday, what should it implement? Yes,
Yes.
speak.
Can you hear me?
Yes, I can hear you.
Yes, I think good afternoon, everyone. I
Good
think the energy manager is supposed to install the ATS, the automatic changeover switch, such that the ATS will have a kind of 2 or 3 contactors that will change over from the grid NEPA to the solar system. So the ATS automatic changeover system, and also they should have a kind of surge protector breaker, surge protector that it can automatically, without manually, the NEPA trip of the grid, it can switch over to the solar system.
Okay, thank you very much. Let's hear from Lois Moses. Lois Moses, you can speak.
Okay, so I'm not an engineer, but I'm guessing maybe like an inverter, because you want to change over and you don't want maybe your power surge to drop because you need to maintain your equipment. So probably an inverter or like a UPS, because I know that like when we have computers, we have like a UPS to maintain electricity depending when you are able to switch over. So I'm guessing that's probably what someone might use.
Okay, thank you for the effort. Engineer Peter.
Yeah, good
Yeah.
afternoon, everybody. Good afternoon. Thank you for having me once again.
Yeah.
Like in a system where you just described to us, ideally, I think first thing is you have to find a way to synchronize all your energy source. So be it grid or off grid and all that. So when that is synchronized, then what happens is that you make use of like the very first contributor said, you make use of a smart changeover switch. So it's automatic. You don't have to, because the synchronization will enable your system to be able to know, even if power is available here, if it's good enough for utility or to be used and all that. So it switches quickly. Then by doing that, you don't have a downtime. Thank you.
Okay, thank you. So the problem here is not about the downtime. Kelvin, you can unmute yourself. Kelvin. Okay. Kelvin, you've been asked to unmute. Okay. Let's hear from Miracle. Now, like I said, the problem is not about the switching, right? Because, of course, the inverters can do the switching. We want to prevent the system from collapsing. If you transfer automatically from this source to another source, there can be a system
Hello?
collapse. Yes.
Okay, so usually it depends on this type of inverter that is being used.
normally as an energy professional, you would need to take account of all the loads that will be going through that particular inverters. And there are some inverters that have surge tolerance. Like for instance, if the inverter is say 10 kVA, sometimes it has a temporal surge output of ×2 its rated capacity. So for some seconds, it can output up to 20 to 30 kVA. So using the right inverter at the beginning of setting up the system can, go a long way in ensuring that there's no system collapse. And another thing that can be done is to optimize the starting of the equipment. So if you have heavy loads, you can maybe use a timer to ensure that they don't all start at the same time. Thank you.
Good. Good. Thank you for that. We have Ronnie. Ronnie, you're not raising you're raising on the chat, but you can raise your hand on this so that you can be called. I want to hear from you. We have Ronnie. You can just click on mute and speak. Okay, let's hear from Bolu Atife.
Hi, good afternoon, everyone.
Good afternoon.
My name is Bolas. Okay, so one thing that can be done, just like the last speaker said, by using timers. So there's one thing that can be done as well again, that from it's not majorly the solar actually can also
Okay, we can't hear you very clearly. Adebayo, can we have you lastly?
Okay, thank you. Thank you for having me. So this is my opinion. How I think this can be done is by load distribution. I am assuming that the load that the grid carries is different from the load that the alternate energy carries. So if we are able to separate these loads, we are able to separate this load by proper load distribution, we can prevent surge. I give example, if for instance, in my facility, I have a freezer, deep freezers, and water heater that I use when there is grid. And for my renewable energy, let's say green and let's say solar, the capacity of my power energy cannot work with those devices. I would need to distribute this load properly so that the grid powers everything. But when I switch over to the solar energy, the water heater and freezer are isolated. That's my input. Thank you. Am I audible, please?
Yes, we heard you. Thank you.
Sorry, you are audible. You are audible. You can speak, please. Patrick, I don't know. I was speaking to myself. Patrick, lastly, let's hear from you.
Once again, I think a lot of the speakers have said most of what I'm going to say. So I think the first thing would be for us to identify critical equipment. And it is important because, for instance, for those who work in a manufacturing firm, we know that there are some things that cannot start without some certain machines being up and running. So it would be very good to place those equipment on maybe a UPS inverter or something like that to ensure that they do not collapse the system. Now, another thing would be to have a system in such a way that loads are well prioritized. I think somebody actually mentioned that too, so that we know that not all loads would be up and running at the same time. To know that, okay, this very load is important, let us be up. Then probably after maybe like 10, 30 minutes, this one comes up, this other one comes up. So that would be like a smart energy management system that would work efficiently to ensure that things go the way they ought.
Thank you. Thank you. Thank you very much. Thank you very much for that. So, I mean, our comments, yes, beautiful. These are some of the things we would learn next week when we come. Because, of course, we've seen that, the mini grid, solar installation, generating power, needs to be something that we must see in the city. Right? Even though we do know that we may not have enough roof spaces and things like that. We'll consider some of these things, when we come next time. So let us just take two questions because we're already out of time, right? So just one or two questions. I'm checking the chat now. I don't think there's any question, huh? Okay, everyone. One or two questions if we have, huh? Okay. One or two questions. To be added to the classroom, yes, you can be added. You will receive an email. Everyone will receive an email, right, to be added to the classroom. You just download the Google Classroom and then automatically you'll be added. So let's just get two questions from Lois will take the first question. David will take the second question and we'll close for today. Yes, let's hear from you, Lois. Yes, Lois, you can speak.
My question is, I still don't understand what the primary metering is all about. I'm not clear on it. The primary metering that you explained previously.
Primary, okay. Yes, in the transformer, right?
Yes.
Okay, yes. So the transformer has two sides, right? We have the side where we call the high voltage or HT, the high transmission side. And we have the side where we call the low voltage or the low transmission side, right? Now, sometimes you see that the meter will be installed in the secondary side. So the lower voltage side is called the secondary. And the higher voltage side is called the primary because that is where the power is coming in before the conversion in transformer is done. And then you now have the low voltage output, right? So the primary is usually where the source is coming from. It's connected to the transformer. I don't know if you get that. So transformer has two sides. You have one side, primary, you have the other side, secondary. You can just think and look at any transformer in your area. You're going to see where the power is coming from is the primary, from the poles, right? From the high tension on the poles is the primary. Then the output that is going into the facility is the secondary side of the transformer. Thank you for that question. David, let's hear from you. David, unmute yourself.
Hello, yeah, can you hear me?
Yes, I can hear you.
So I wanted to ask a question regarding to the general class and then a question regarding to the classes. So let me start from the general one. The PDF documents that you uploaded on the Google Classroom, I've been unable to download them. I don't know. I've been struggling with it over and over again, and even the assignment, I did it before Monday 9 a.m. But I've been unable to submit. I don't know. Maybe there is a way you can then be able to just guide us on the process so that
Okay,
we
are you on
can
the
know.
WhatsApp group? Are you on the
Yes, I
WhatsApp
am.
group?
I am. Yes, I am.
Okay, so you drop it there, Kike would assist you, or Abba will assist you with it.
Oh, okay. Regarding that, then
All right.
regarding today's lecture, firstly, I just want to speak about the strategic solution for energy managers, and then I will speak about the transformer losses. Maybe I should start from the transformer losses rather. So
Okay.
one thing I know is that we have a facility where I worked. We have 11 kVA power supplies, the step down transformers and everything. But
Okay.
the way NEPA sealed the access, it is very much impossible for you to access what exactly is going on. There was a meter that reads the consumptions. So after a while, we just discovered that maybe the glass was blurred and we couldn't read what is going on. Then we raised a complaint to them over and over again, and nothing has been done. The only thing they say is that don't worry, we know how we can check what you guys are using from our own office. So the aspect of this primary and stuff, there is a way PSCN people there is a way they just protect the assets that it becomes so very difficult for you to access to see what's going on, even if it's on primary source. How did you go about it? Because we were raising an analogy regarding a facility like that. How were you able to go around it in resolving it? Sure, you understand?
Okay.
Then the second question I wanted to ask was on this solution for energy manager. One thing I've seen in the past is that there was a particular place where I was working some times ago. It was an hotel facility, and then they used an inverter to power up their essentials load and everything. So I was thinking, I know it is possible when you have a chunk of load. I was thinking that some specific load, maybe the lighting, the TV, the CCTV camera, some specific load can just be taken out, and those loads will be powered by solar systems. So automatically, those loads are always on solar. So every of our high consuming equipment, ACs, pumps, and all of that can be channeled to the grid or generator of wherever for metering. So I know it is possible. I just wanted to explain how that can be achieved.
Okay.
Thank you.
Okay. All right. Thank you. So for the first one, right, you have the right to get to see your meter because that's what you're used to be billed for, right? So you should have access to it, and you should also ask them to train you on how to check it. And of course, whenever they are coming to check it, you can also have someone be with them. And the second thing you can do is installing a meter at the secondary site for your own purpose. We can then calculate an estimate loss, right? For the conversion, using the formula and have it as a compensation, right? Now, so if the secondary side of the meter is reading, let's say 500, we'll add the compensation value that we have looked at, right? To that, to give us an idea or to give you an idea of what your bill should be. Because as energy manager, we should not be reactive. We should even know what our bill would be before the end of the month so that it can be managed, right? So on that, we can talk more with you on that. If you're on the group, you can drop a message, more discussions can come on that with you. The second is, yes, what you said regarding the load shedding is also valid, especially, like you said, some of the loads can be put on the solar system and while some will be put on the grid. But now, this is where the issue also may be, because if your generator is sized for the total load, then you now need to consider that it's either you drop down that generator sizing, right, to accommodate for the actual load you want to power. If not, the savings you are having from the solar, you burn it on your generator. Because if, for example, my generator is supposed to be a 500 kVA generator size to power this facility, and I take out, for example, 150, 200 kVA load out of the generator. That's an example, right? That means that my generator can only cater for 300 kVA. And once there is no grid and I put it on 300 kVA and I'm burning a 500 kVA generator, I might be losing, which is some of the calculation we'll do next time on how to calculate our loss. I might end up losing, say, 20 to 30 liters per hour, right? Whenever the generator is running. And when we calculate it, we now look at, is it even energy? Am I, they said twice, two step forward and 3 step backward, 1 step forward and 2 step backward, right? So, of course, what you said is something that we've noted. We can also discuss it personally and see how we can fit in, suggest to you what you can do, energy solution you can look at for. And also, from this session that we're having, we will also be looking for partners, looking at their profile. If you're working for a firm, you have a good profile, we would also put up a form so that we can get them and then, look at introducing you to some of them for them to implement some of these solutions for you. But for us, we are into metering, monitoring, gas, energy, power, diesel, anything monitorable, we can monitor it. And that is what we are specialized for. So thank you very, very much for this interactive session. Before we close, how was the session? I want to get just some feedbacks. How was the session? Is this method, because this is the method we want to adopt so that it's more interactive and it keep people engaged. I will want everyone to get engaged at the end of the day. So how was this session? Let us get some comments on how the session was. If you enjoyed the session, can you give thumbs up, thumbs up, thumbs up, thumbs up? Informative. Thank you. Thank you. Thank you, Jimo Said. Wale Sunday, thank you for your participation. Yes, Kola Wale David, thank you so much. Kelvin, we enjoyed your comments. Yes, so let's keep the energy running. Let us join the classroom, Google Classroom. There will be assignment there. We're going to learn together, grow together, and we want people that are energy managers, right, for the future. So this session is also recorded. The recording will also be dropped so that we can get to what's it called? Get to watch it later for other times. Let us enjoy the rest of our day and let us stay blessed. We'll see you next Wednesday, same time. Bye for now.